Good morning everyone. Today we will learn how to find determinant of a higher order matrix. We all know the procedure of finding determinant of order 1, 2, 3. But when we use that method to find determinant of order 4 or greater, then that procedure becomes so lengthy. Now to replace that lengthy procedure by a easier one, we use this algorithm. Reduction of the order of a determinant. The following algorithm reduces the evaluation of a determinant of order n to the evaluation of a determinant of order n minus 1. In simple word, if we have a determinant of order n, then using this algorithm, we can make it of order n minus 1, that is 1 order less. Now to start this method, first we need to take a non-zero n square matrix A. Now you know that when we talk about determinant, we always need to take square matrices. Now come to the first step. Step 1. Choose an element Aij equals to 1 or lacking, choose any non-zero Aij. That is, if the matrix have any 1, then choose that element. If there is no 1, then choose any non-zero Aij. After choosing, come to the second step. Use that Aij as pivot element and make 0 at all other positions in the column or row of that Aij using elementary row or column operation. And step 3. Expand the determinant by the column or row that contains Aij. This is our whole procedure. In note, we use this method for the determinant of order 4 or higher. Now let us take an example to make this explanation more easy. Here I take a matrix A such that, say it 0, 2, 2, 0, 2, 0, 1, 1, 2, 2, 1, 2, last row 2, 2, 2, 0. This is a 4 order square matrix. Now we need to find the determinant of A. This 0, 2, 2, 0, 2, 0, 1, 1, 2, 2, 1, 2, 2, 2, 0. We need to find the value of this determinant. Now see that if we try to expand this determinant with respect to any row or column, then we will get 2, 3 or 4 numbers of 3 order determinant. And again we must need to solve them, which is a very lengthy way. To make this lengthy procedure short, we now use our algorithm. The first step is choose an element which is equals to AI equals to 1. See, in our determinant we have 3 ones. You can choose any. Step 2. Use Aij as a pivot element and make 0 at all other positions in the row or column containing this Aij using elementary row or column operation. Here you may take column or row as you wish. Now see that this one has now see that the row and column of this one have all non-zero elements. The row of this one has a 0 element. Now if we choose this one, then in the column of this one, here is already 2 0 element. So if we can make this 2 equals to 0 using elementary operations, then our purpose will be served. Now to make this 2 0, replace the third row by, replace R3 by R3 minus 2R2. And then we get 0, 2, 2, 0, 2, 0, 1, 1, minus 2, 2, minus 1, 0. In third row, we apply this operation. And last is 2, 2, 2, 0. Now we all know that if a multiple of a row or column of a matrix were added to another row or column of that matrix, then the determinant of both matrix will be same. So this and this matrix are equal. Now come to the third step. Expand the determinant by the column or row that contains Aij. Here we use the operation on column of 1. So we expand the determinant with respect to this column. Since all other elements are 0, we need to take the minor which is corresponding to 1. Now this position is 8 to 4 position. So the sign of this minor will be minus 1 to the power 2 plus 4. Now to get the minor, delete second row and fourth column. That is the row and column of the element, pivot element. So the remaining portion is 0, 2, 2, minus 2, 2, minus 1, 2, 2, 2. See, this is a 3-order determinant. We start with a 4-order determinant, and using this algorithm, we get a 3-order determinant. Now treat this as a 3-order determinant, and I expand this with respect to the first row. And then we get minus 2 minus 4 plus 2 plus 2 into minus 4 minus 4. That is, the answer is minus 12. This is the whole procedure. Now, if we have a matrix of order 5 and need to find the determinant of this, then we apply this algorithm and get a determinant of order 4. And again, applying this method, we get a determinant of order 3. And then we use this procedure. So, if we have a matrix of higher order, then to find the determinant, we just need to apply this procedure repeatedly. So that's all. Thank you.